the RSNA, this is the Radiology Artificial Intelligence Podcast. My name is Paul Yi, and I'm a radiologist at the University of Maryland and co-host of the podcast.
And my name is Ali Tejani, and I'm a radiology resident at the University of Texas Southwestern Medical Center and co-host of the podcast. Each month, we dive into the hottest topics in radiology AI and talk with leading experts, thought leaders, and movers and shakers in the field. When you attend RSNA 2023, our industry influencers and radiology trailblazers are set to help you embrace what's next in medical imaging. Imagine what new medical imaging practices and technology can teach about collaboration and innovation. We have everything you need, all in one place, as we help you explore how to lead through change. Join us November 26th through the 30th for the biggest week in radiology, in person, virtually, or both. Early bird pricing is available through October 4th. Register now for RSNA 2023 at rsna.org/register. Welcome back to another episode of the Radiology AI Podcast. On this episode, we continue with part 2 of our conversation with Drs. Felipe Kitamura and Bardia Khosravi about generative AI. Hear more about where we can focus our research efforts to help shape this field as it continues to evolve.
Felipe is a neuroradiologist, Director of Applied Innovation in Artificial Intelligence at DASA, and affiliated professor of radiology at Universidad Federal de Sao Paulo. He's interested in leveraging the latest technological advancements to improve patient care. Bardia Khosravi is a medical doctor and currently a postdoctoral fellow at the Department of Radiology at the Mayo Clinic. He's also an incoming member of the Radiology Artificial Intelligence Training Editorial Board. His research focuses on generative AI and its applications in medical imaging. So speaking of new developments, Bardia, you've been working with generative AI for a while now, and most recently at the SIM annual meeting in Austin, Texas, you actually won the Best Scientific Paper Award for some work with generative AI for pelvic radiograph synthesis. Can you tell us about your research and some of the inspiration for it, what you found, and what you think the next steps are?
Yes, so we presented our work titled Generating High Fidelity Conditional Radiographs Using Diffusion Models. So diffusion models are a group of generative models that create images from pure noise. So you start with noise, you gradually denoise them using a deep learning model, and you come up with a clear model, a clear image at the end. And there are some foundational models that are trained on large corpus of images and text together to create these diffusion models. So if you have worked with DALL-E 2 or Stable Diffusion, you see that you can input a text prompt and they will generate a high quality image for you that's very close to what you asked them for. But if you ask them about medical terms or medical images, they come short. They create very artistic images, but not very realistic. So we wanted to create a diffusion model that is conditioned to create medical images. And for this work, we specifically chose pelvis radiographs because we had a very large repository of them at our institution. And what we found is that these models are very good at sticking to the conditions that we give them, even though the radiologists cannot detect them. So for example, when we asked radiologists and surgeons to evaluate real and synthetic images, they only had an accuracy of 57%, which is a little bit more than a coin flip. And in specific criteria, such as patient's age or BMI, they didn't find any difference between real and synthetic images. And this is very interesting to us, meaning that these models can grasp the data distribution very well and can fool experts. So the next step here would be, now we have this rich data, real, and we can accompany it by a set of synthetic data. Will this help first improve our model, our downstream models? Second, can we dig a little bit deeper into our own data and see what are the nuances of our data that we couldn't understand by just manually looking and checking each and every radiograph?
Yeah, that's super interesting. I'm just curious, how much compute did this take? About how long did it take to train a model, and what kind of GPU were you using?
For this, we had 480,000 images to start with, and these are all the real images. And we characterize them using several deep learning models. So these are all the labels come from different models that we developed during the years. And we use classes, the class labels to condition the model. And it took 380 A100 hours. Comparing
Wow.
it with, let's say, free text conditioning, that was the previous work published last year from Stanford, it's for now 4 times more faster. Which for free text prompting, they trained the model for 1500 A100 hours, which is much more. So at least if we have the labels, it will make the model's job much easier.
That's pretty incredible, Bardia. I'm curious to, well, maybe hear the group's take on this. What does this mean for things like IRBs and human subjects research versus non-human subjects research? Because, I can see a future where we take maybe the entire hospital's worth of images, but we create synthetic images, and they're technically not of a human, just like this is not a face or this is not a real human face. And we could potentially just start doing things at a scale that, really hasn't been possible for public data, for quote unquote non-human subject research. I know that, Felipe and I have talked about potentially sharing data, and that's always been a tough thing just because of data use agreements and things like that. So I don't know. I'm curious. Maybe Barty, you guys have talked to the folks at Mayo, or maybe not. What do you guys think?
So still, it's a little bit challenging to convince people that this is not real because they look really real. And we should be very careful with the paper that coming out that say sometimes these models can generate real training sample images. And that's a challenge that we have to be very careful about. And there are some conditions that you can control for to make sure that this happens at least very few times, but there is something that we have to be careful about. The other thing that I wanted to mention here on our previous work with GANs, now with diffusion models, but with GANs, we showed that when you share some synthetic data with another institution and train a model on their real data plus the synthetic data from our institution, the model is much more generalizable on the source institution, which was ours. So at least this, if you're working on some problems that needs a little bit of that you want to have a final model that works well on several institutions, at least having some samples of their real data created by a generative model would help with the generalizability.
So what I'm hearing is there may still be a role for federated learning and some of the processes that have been coming into play here over the last few years. But Barty, one thing that your comments make me think about are, I guess it was a preprint, like an archive paper that talks about one group's attempts and experience trying to address gaps in a data set. They use synthetic data, generated data, and they found that their model, what they call is a model collapse. So I haven't seen much more on this. I imagine we're going to start seeing more as groups start to approach this same problem rather similarly, maybe with a different use case. But I don't know if you had any thoughts on model collapse, or if your group had thought about that at all as well.
So first of all, I think the paper you're referring to was the large language model paper, right? And they say we theorize and they show that this is generalizable to other types of models. Am I correct?
That's right.
Yeah, okay. So that's a little bit tricky because there is a paper, I think, it was published around the same time that shows if you train your large language models for more than one pass over the data, it will cause the same phenomena. So if you see the data twice, it will cause the same phenomena. So I don't have actually enough knowledge to say if that's only for large language models. We don't see this phenomena in image generation models. So we train them for example, this model was trained for 40 million images, to see 40 million images in iteration, but they're still the same. I still think that there is room for augmenting real data with synthetic data, but using pure synthetic data is something that should be explored, but with a little bit of caution.
I think that's very well said. And so as we think more about what's next, and Felipe, I'll direct this question to you if that's okay. And I struggle with this myself, right? There's a lot going on in this space, and the researcher in me wants to jump in. It wants to contribute, wants to help push our field forward. It's hard though. It's hard to think about, well, what's going to help the field, allowing for the time gap it takes from the generation of an idea to planning to execution to submitting and publication. That's a long process, and it can be intimidating for many researchers. But if there are researchers listening to our podcast, where should they focus their efforts on if they want to help shape this space? What's their best bet?
I think that's also an excellent question, and it points to the exciting landscape of possibility that we have. I would argue that ChatGPT is in many ways, a fantastic potential for AI, specifically in healthcare. We know that some people consider ChatGPT not to be general AI, but it's definitely not narrow AI anymore, right? It's something in between that. Every day we see researchers pushing the boundaries, discovering novel applications of ChatGPT, from facilitating patient communication to aiding in medical literature review. There's a wide range of early stage experiments that people are doing, but translating these experiments, these tests, into robust, safe, and reliable clinical use still remains a significant and largely unmet challenge. Researchers interested in shaping this space can play an instrumental role here, I think. We need more minds engaged in rigorous evaluation and refinement of these models. This includes conducting systematic validation studies, investigating and addressing potential biases, ensuring that these tools integrate seamlessly into the existing workflows as well. We also need, I think, research on the broader ethical and societal implications of using AI in healthcare. And this includes considerations of data privacy, informed consent, how we maintain the human touch in the technology-mediated care paradigm. I think we are at a point that we are about to see another revolution in healthcare that is being caused by AI. The future will be shaped by those who dare to dream, who are willing to navigate the uncharted territories, and who have the tenacity to turn these early stage use cases into clinically safe and reliable applications. So for those looking to make a mark, I'd say dive in. The waters are deep, the current strong, but the opportunity for a meaningful contribution is enormous.
Well, I think that's very inspiring, Felipe. And I do wonder, though, as we think about all of the exciting technologies coming out, is there still a role for some of these older transformer-based models? I mean, they're not really that old, but I guess in terms of the pace of the field, they might as well be, well, maybe some people might say they're ancient, but I wonder if there's still a role for these older models like the BERT-based language models.
Absolutely. Actually, we were talking about that, Ali and I, the other day. Every time there's a new technology, we usually tend to think that this is the new thing and it's going to solve everything. And now everybody is going to just use that, right? But I guess there's a role for these older and also smaller transformer-based bundles, because since they're smaller, they're easier and also cheaper to train, right? We can train them a lot faster as well. And another thing is we can run them locally on premise. We don't need, huge amounts of GPUs in the cloud. We don't need to pay someone else to do inference or to fine tune that model for us, because we don't have the infrastructure to do that. I'm comparing to large language models here. So I do think there's a space for these models. And another issue is, since you can run them locally, you also solve a big part of the privacy issues with protected health information. because the data is within your firewall in this case. Of course, we know that these smaller models are not gonna have those emergent capabilities, things that we see in these larger models. We shouldn't expect these models to be able to write a radiology report in a Shakespearean prose, for example, or solve a complex math equation. But if your use case is just summarizing a radiology report, you don't need it to do anything else, right? So this is why I think these older transformer-based models are still have a role to play in the field.
I think that's absolutely on point, Felipe. And going to your comments here and kind of where we should focus our efforts, I really hope we can start seeing more quality control frameworks, more governance. And maybe I'm being way too optimistic, but I do think we're going to start seeing translation, what's now emerging, AI, right, to the clinical domain. But once we're there, I hope our field is ready to assess the output before it gets to patients, it gets to non-radiology clinicians. Hopefully there's AI monitoring has gotten to a point where we can actually have robust systems in place and be ready for the revolution. Is the revolution or the evolution that you mentioned?
One thing I'd like to add to Felipe's point is that I don't know, you probably seen it in the past couple of days, that it's reported that GPT-4 is not one model. It's actually an ensemble of multiple models. They work with each other to have the best output out there, to have the best output. So I believe that in the final use case, we'll have a large bag of models that will help us in our tasks. Some of the tasks should be done by, let's call them lower level, older transformer models, like the BERT and Roberta. And then they sanitize the data and they pass it to a higher level model for higher ordinal reasoning to, let's say, extract some information, summarization. So a very good example is the Stanford Amy de-identifier. I don't know if you've probably worked with this, but if you look at their Hugging Face, you see a very big spike after the introduction of ChatGPT, because everyone is trying to de-identify their reports or their medical text using a very simple BERT model, and then use that de-identified report to feed it to online models and see how they work. So I think there is a room for, I think the best advantage that these older models give us is their smaller nature and the fact that we can run them on premise and help preserve patient privacy, and then feed the results to a larger commercial model.
That's exciting. I don't know. Things, like ideas like that give me goosebumps. So, Bardia, I want to say thank you. There's so much to look forward to. I want to take this moment now to see if anybody had closing thoughts. I'm sorry we have to end our conversation. What do you think?
I think we're living exciting times. There's a lot of opportunity there for people who want to do research. We are always concerned with patient safety, the quality of the healthcare we provide. I think there are ways we can leverage these new large language models to take a step further in all those projects that we all have been trying to make it better so far. Those projects related to patient safety, healthcare quality. I think we should look at the old problems we have, also healthcare costs, for example, and see it from a new perspective and see what we can do with these new tools to try to at least mitigate those old problems.
I think now it's a very exciting time to be alive. So I don't know if you've seen the 2-Minute Papers YouTube channel. That's their motto. And I think that's amazing. And that really translates here. I think with the emergence of generative AI and specifically large language models, there's a much bigger room for creativity. And the idea behind each research project or financial project, whatever. But I think the role of creativity is now much more bold than what was, let's say, 5 years ago. 5 years ago, you had to know how to code something. how to come up with all the steps. But now you have a very powerful tool and you just have to imagine and ask it.
To Bardia's point, I totally agree that coding has become a lot easier. Andrej Karpathy, who was the director of AI at Tesla, once said on Twitter that he have seen 2 or 3 times increase in his coding efficiency. And I've also seen that happening to me. And I'm far from being as proficient as he is in coding, and I've seen also some gains in coding. So I totally agree with Bardia that these are exciting times to be alive.
All right. Well, I totally agree. I think it's an exciting time to be alive, and it's an exciting time to be listening to the Radiology AI podcast. So, Bardia and Felipe, thanks so much for being here on the show. Really appreciate your time.
Thank you so much for having us.
Thanks for joining us for this episode. We hope you enjoyed the conversation just as much as we did.
Subscribe to the Radiology AI podcast for more discussion on content from the journal and hot topics in our field of AI and imaging informatics. Thanks to all of our panelists involved in the conversation. Thanks to you for listening.
We hope that you've enjoyed this episode of the Radiology Artificial Intelligence podcast. Shout out to Uriah Shemchison for our podcast music and to the RSNA podcast staff.
Email us at podcasts@rsna.org anytime with questions, feedback, or suggestions.